Alright, this is from the Honors Purple book, Chapter 3. This is Lesson 1. I'm dealing with constant rate of change. I'll be doing the guided practice off page 174. Number 1 says, the amount of paint Y needed to paint a certain amount of chalk X, X, is shown on the table. Is the relationship between the two quantities linear? So let's talk about that word linear. Linear means if you graph them, they go in a straight line. Okay? Which means, really the definition that we're going to be using here is they have a constant rate of change. Constant rate of change can be found with the formula y of 1 point minus y of a second point divided by x of 1 point minus x of a second point. I always just say the difference of y divided by the difference of x. Difference of y over difference of x, which a lot of people know as rise divided by run, because the difference of y, there's your y-axis, the difference of y is how much is going up or down. The difference of x is how much is going left or right. Okay, so that's the way we're going to tell if it's linear. Then the rise and the run, rise over run, should be the same for every point. Okay, so I'm going to take that first one, has the point 5, 6, and 10, 12, and 15, 18. And I'm going to do difference of y over difference of x. So let me do a subtraction problem here. Difference of y, I get 6. Difference of x, I get 5. Difference of y, I get 6. Difference of x, I get 5. So we have a difference of y being 6, a difference of x being 5, and it was the same each time. So that 6/5 is your constant rate of change, which makes this a linear relationship. If you graphed it, it would be in a straight line. Okay. Second one. The altitude of y of a certain airplane after a certain number of minutes x is shown in the graph. Is the relationship linear? Once again, we need to see, are they in a straight line? Do they have a constant rate of change? Is the difference of y over difference of x, is that constant? Does it stay the same? Is the rise over the run exactly the same? So I'm going to grab a couple of those points. There's one that's a little bit hard to read. They all look like they're in a line, but one of the points there is 2, 3,000. And another point is 6, 2,000. The problem is if you only use 2 points, you'll always have a constant rate of change between 2 points. So we're really going to have to find that third point, even though it's a little bit hard to read. Okay? So if I do the difference of y, I subtract, and I get 1,000. Difference of x, 6 minus... No, wait, no, this is 3,000 minus 2,000. You have to go in the same order. 3,000 minus 2,000, I got 1,000. So 2 minus 6 is negative 4. When I divide that out, it becomes negative 250. So let me see if I can read that other point. That other point looks like it would be 3,500. Is that right? We have one that has a 0, so 3,500, I believe, is what that is. Okay, well, let's check that difference of y over difference of x. Okay, so difference of y here. I'm going to subtract this way this time. 3,500 minus 2,000 is 1,500. 0 minus 6 is negative 6. So when I divide 1,500 by negative 6, once again I get negative 250. So is it linear? Yes, and your constant rate of change is negative 250. What that means is the altitude is dropping 250 feet every hour. Okay, number 3, determine whether a proportional relationship exists. Now it's asking about proportional. The difference between proportional is this tells you if it's linear. If they have a constant rate of change, it's linear. But if the y divided by the x of every single point is exactly the same, no subtraction necessary, if this is true and the same every time, then it's linear. So when I look at that one, go back to exercise 1, back to this 5, 6, 10, 12, and 15, 18. If I put that in y over x, that's 18 over 5, 12 over 10, and 6 over 5. If I divide all of those, that was 18, 15. 18, 15, 12, 10, and 6, 5. If I divide them all, I'm going to get the exact same thing. I'm going to get 1.2, I'm going to get 1.2, I'm going to get 1.2. So 1.2, since they all match, that is also proportional. And that 1.2, or 1 1/5, if you want to do as a fraction, would be the unit rate, the constant of proportionality, right? the constant variation, all of those things that we've talked about, all the terminology. All right, number 4. How can you use a table to determine if there's a proportional relationship between two quantities? Well, a table, if you have x and you have y, and you want to know if these are proportional, take numbers like 3, 12, and 5, 20, and 8, 32, and we'll know if that's proportional. Well, put y divided by x, because proportional, remember, you have to have y divided by x always be the same, not just the subtraction. Okay, we can do that. I'll show you the subtraction also. If I do difference of y, I get 8. Difference here, 5 minus 3 is 2, and then 8 divided by 2 is 4. So the constant rate of change between those is 4. Here I have a difference of 3 and a difference of 12, and 12 divided by 3 is 4. So they have a constant rate of change. It's linear for sure. But now let me check the constant proportionality. 12 divided by 3 is 4. 20 divided by 5 is 4. 32 divided by 8 is 4. So they do have a constant of proportionality, constant of variation. In fact, there's your equation. No boyfriend on the back. It is proportional.